So children, we move on to your exercise 2D second video. This is my 9th video lesson on rational numbers. So we saw in the first video of exercise 2D how we subtract two given rational numbers. Now in this part we are going to do problem sums on subtraction of rational numbers. So from question 6 to 10 of exercise 2D we have problem sum. I am going to do all the even numbered sum. You can try odd numbered sum. So if you are following any other book also, the basic idea remains same, and I'll show you question 6 also is same format over here. So sum of two rational number is given, one of them. So one example I am giving you children whenever you do. Let us take example, sum of two number is 17. Sum of two number is 17. If one of them is 7, so same way sum of two rational numbers, 17 is also a rational number, is 17 and one of them is 7. What is the other? So we subtract from the sum of the number, the other number is this 17 minus 7, 10. So this same logic. One sum of the number is this, one of the number is this. What is the other? Sum of the number minus one of the number. So sum of the number minus one of the number. So it will be this minus this. Or from the sum you subtract one of them, you will get other. LCM will be 16. 8 will go 2 times. So minus 5 will be multiplied with 2. 16 will go 1 time with 16. So this is there. So we get minus 10 minus 7 by 16. So our answer is minus 17 by 16. So you just see that we have got the LCM and we have multiplied. 8 goes 2 times, so we multiply by 2. 16 goes 1 time, so both the number minus. I had in previous video I have told you that when both of them are minus you add them, but minus sign comes. Don't convert it to mixed fraction because we are doing rational number. So very same, pause the video and we will do number 6, so which is almost exactly like this only. So children, sum 6 has exactly the same format as sum number 4. So other number is, as I taught you in the previous sum of the number minus the second number. So here the sum of the number is minus 5 by 4, one of them is minus 3. So as I taught you in the previous sum, subtract this from this. So once more, this minus minus will become only the sign, we don't take product, children. As I taught you, actually minus means we add the additive inverse of minus 3, which is 3. Now take LCM will be 4. 4 will go in 4 1 times. So 5 will be minus 5 will be multiplied once. 1 will go in 4 4 times. So multiply 3 with 4. So we get minus 5 plus 12 by 4. So our answer is 7 by 4. So kindly see how we have got 1 as in the denominator. We get LCM 4. 4 goes 1 time, so this is multiplied with 1. 1 goes 4 times, so 4 3s are 12, minus 5 is 7. 7 by 4 is our answer. So kindly pause the video and copy, then we'll move on to question number 8. So we move on to two very interesting questions from exercise 2D. question 8 and question 10. So this sum both can be done in two ways. I'll try to show you. First way, let us see method 1. What should be added to this to get this? Take a simpler example. Don't take rational number fraction. What should be added to 5 to get 8? What should be added to 5 to get 8? So you will see 3. So other way of saying, what should be added to 5 to get 8? What should be added to 5 to get 8? So actually what we get, 8 minus 5. So what should be added? So what we will do, we will subtract from this. So once more, what should be added to 5 to get 8? So actually we get this way. If you see, so it is, I'll show you by x also, it will be 8 minus 5. So let us see, 5 is the LCM, 1 will go 5 times, so this will be multiplied, minus 1 will be multiplied with 5, and 5 goes 1 times, so 1 into 2, so we get minus 5 minus 2 by 5, so answer is minus 7 by 5. So this is one way of doing. Method 2, children, same sum I am showing. What should be added to this to get this? So we subtract this from this. What should be added to 5 to get 8? So it's actually 8 minus this minus this. If you have any difficulty in this, second one will be easier. So let what should be added? Let x be added. Let x be added to 2 by 5. So this be added to get minus 1. So what happens in this method? Let x be added. So this plus this is minus 1. X will be on this side, this will be transposed. So ultimately, children, you see, we get the same thing. Let x be added, we get this, x remains here, this becomes minus. So ultimately, if you see, we almost get same way and same answer. Okay, so kindly pause the video and copy, then we move on to the very last question of this exercise 2D, and we will see how we do that. So this sum 10, the last sum of exercise 2D, I'll try to show you by both method. Method 1, what should be subtracted from this? So what should be subtracted from this to get 1? Children, this is 1. So what should be subtracted? Let x should be subtracted. So this minus x, we get this. So if you solve x, take it to other side, it becomes plus. For some children this may be easy, but for some children my method 2 will be easy. I think for most of you, method 2 you can see. So here this is minus 2 by 3, 1 comes here, so minus x becomes plus x, plus 1 becomes minus 1. So if you take LCM, children, you will get 3. So 3 ones are 3 and 1 will go 3 times. So finally we get minus 5 by 3 as x. So this is one of the method. Now second one, I'll tell you how we do. What should be subtracted from, suppose, for example, you take what should be subtracted from 13 to get 10. What should be subtracted from 13 to get 10? So we know we will subtract 10 from 13 and we will get 3. So see here, question is what should be subtracted from 13 to get 10? So we know 3. How we get 3? 13 minus 10. So this minus this. Ultimately same thing once more. what should be subtracted from 13 to get 10? So you will say, sir, it is 3. How we get 3? 13 minus 10. So same way, what should be subtracted from this to get this? This minus this. So think over it, pause the video, play back, and go back. You will get the same logic and same answer. So any one of the method you like, you can do. So pause the video and copy, and almost everywhere, any book you are using, you can see most of the sums are very similar, only numerical values may be different. So almost half of the exercise I have done, other half of the exercise you try, and there are many good solved example also. Please do the solved example also. So practice, because practice makes a man perfect. Thank you boys for watching.